Okay, no dumb little joke. You're welcome. No little story. We're going to dive right into Mass Stoichiometry. Bit of a change of scenery, but that's okay. The thing about stoichiometry is that a lot of students find it somewhat, let's say, intimidating. Really hard. But it's actually not all that hard. I mean, it's going to look kind of confusing because we take fairly simple math and we're going to dress it up. But the math that we're doing is very, very simple math. It's add, subtract, multiply, divide. And the steps we are doing, and there's going to be three, are the same steps every single time. So it's very, very process based. If you can get the process and you can kind of get past the dressed up math, it's actually a really, really simple concept. Before we start talking about stoichiometry, though, we're going to talk about sandwiches. And I actually did say sandwich rather than sandwich, but yeah, blame it on the upbringing. Let's say you want to make a sandwich that has 2 slices of bread, 1.5 slices of tomatoes, and 4 strips of bacon. And that you put together and you make yourself a sandwich. That's the recipe of the sandwich. And every time you do a sandwich like that, it's going to be 2 pieces of bread, 1.5 slices of tomato, 4 strips of bacon. And it doesn't matter how many sandwiches you make. So let's say you decide you want to make 5 sandwiches. Okay, so you're going to take all of this and you're going to scale it up. And you want to end up with 5 sandwiches here. Well, of course, that means you're going to need 20 strips of bacon, and you're going to need whatever 5 and times 1.5 is, 7.5 or something like that. And you're going to have 10 pieces of bread. I think this is 7.5, so we'll write that down. On the other hand, if you decide to make 500 sandwiches, or if you decide to make 5,000 sandwiches, the recipe will be the same. It's just you scale it up every time. All right, going back to stoichiometry, the chemistry side of things. So what is stoichiometry? Stoichiometry, and you probably want to know this, it's the mass relationships within a chemical reaction. And that's kind of important. The next line you don't have to write down so much, but if you think about the sandwich example, what we were doing was we were scaling up, taking the basic recipe, for us that's going to be a chemical reaction, taking that basic recipe and scaling it up into other amounts. You don't need to write this down, but if I give you a chemical reaction and I ask you to tell me what it means, you would probably take this reaction, for example, and read it as molecules and atoms. So 1 molecule of nitrogen reacts with 3 molecules of hydrogen to make, well, in this case, 2 molecules of ammonia. That's okay, except in reality we're rarely dealing with molecules and atoms, at least not in amounts where we could actually be able to count molecules and atoms. We're usually dealing with much, much larger numbers, which is why we need the mole. But let's start with counting molecules because that's where we're comfortable, that's what we're familiar with. So taking this reaction, how many molecules of hydrogen do you need to make 72 molecules of ammonia? Now, what you need to know is that here's what I'm looking for, here's what my target is, and also here's the recipe. 3 hydrogens are going to make 2 ammonias. Now, of course, in order to do that for real, I would need the nitrogen, but for the purposes of this question, I could ignore it. How many sandwiches could I make from 10 slices of bread? Nobody asked if I was using bacon or bologna or anything else. So we start with our basic recipe, 2/3, and I like to put the thing that I'm looking for on top. So my x is on top on the side of the ratio where I don't know what I'm using, and so I put h on top for my the side that I do know. Solving that ratio, I end up with 108. Now if I can just get you to think it for a second about math that you've seen before, just ignoring all the labels, if I asked you to solve that ratio for x, that would be really simple. You did that in grade 9, perhaps even elementary school. We're doing the same stuff. All we're doing is we're adding labels to keep track of all the other things that we've got going on. All right, let's move that into counting with moles because that's really what we need to be able to do. We can take the same reaction. We're going to take a similar situation, but now I want to look at this reaction in terms of moles. So instead of looking at the balancing numbers and the chemical formulas as numbers of molecules, now numbers of moles. Nothing has changed. We're counting different ways, but now we're we're still using the same numbers. So 1 mole of nitrogen reacts with 3 moles of hydrogen to make, well, 2 moles of ammonia. So counting with moles now, the question is kind of similar. How many moles of hydrogen are needed to make 4.8 moles of ammonia? The only real difference now, I mean, yes, we're counting in moles, but we've also got this decimal. We're going to do it the same way. We're going to look at the fraction based on the recipe that we have, and we're going to make that as a ratio with the thing that we don't know. So I'm still looking for the same unknown, hydrogen. So my ratio is going to look a lot alike. And again, if I just focus on the numbers and ignore the labels for a moment, I need to have the labels, otherwise I'm going to probably forget what I'm trying to do. But if I just look at the numbers for a minute, the question actually becomes very, very familiar. Solving that, 7.2 moles of hydrogen. Now, if you're following along, and obviously you are, but get out your calculator, push the buttons, calculate these answers as well, so that you actually can make some sense out of where these numbers are coming from. Because if you're just watching it happen, you're really not going to be able to do it on your own later. So let's try another one, and we'll do it together. Same reaction, except now we're going to mix it up a little bit. How many moles of nitrogen are needed to react with 7.58 moles of hydrogen? So now I'm looking at the two reactants, which means I don't need to worry about the products. Of course, if I have reactants, I'm probably going to have products, but for the purposes of this question, I don't need to worry about it. Set up the ratio based on the recipe. Again, I like the thing I'm looking for, my unknown, to be on top, so that puts X moles of nitrogen on top, which means my 1 mole of nitrogen goes on top. So I've got one part of my ratio coming from the balanced chemical reaction, 1 and 3, and the other one coming from the numbers I'm given in the question. Solving that ratio, 2.53 moles of nitrogen. Again, if you don't have your calculator with you, use the one on the computer, find one on your iPod or your phone, but push the buttons. Okay, get the answers yourself. I'll give you this one on your own. Different reaction. How many moles of oxygen? So here's oxygen, which means here's the number I need, are used to produce 5.6 moles of water. So here's the other one, and I'm not producing 14, I'm producing 5.6. So now I've got a different unknown, a different X, and I'm looking for something else. But the reaction is going to work on this recipe, 19 oxygens, 14 waters. So hopefully you paused it and you worked it out, but to double check your answer, 7.6 moles of oxygen. Okay, here's where we get into more of the true stoichiometry. And stoichiometry, of course, was the mass relationships. So right now, all we've used is molecules and moles. We need to get into masses. So don't write this down, but this is the kind of question that we're talking about. Or this one. Again, don't write it down because I'm going to give you a different question in a moment. Okay, here's the question we want to work with. So same reaction that we've seen a couple times, so we're familiar with the ratios, but now we're talking about masses. What mass of hydrogen is needed to required to react with 31.6 grams? Now really, really important, you cannot, absolutely cannot go from mass to mass in one step. There's going to be 3 steps every single time. I'm going to tell you the steps, we're going to work through the steps, and then we'll try and combine them all together at the end. Our first step is convert the mass that you know, which was 31.6 grams of nitrogen. Convert that mass that you know into moles. Oh, how do I do that? Well, that is our triangle. Mass on top, number of moles, molar mass. So we already know how to do that. Okay. So in this question, it becomes how many moles of nitrogen are in 31.6 grams. Now I'm going to put that in brackets because I'm not changing the question, but I just want to think about the question just in that piece. 31.6 grams, what does that mean? Well, I divide it by its molar mass. Molar mass of nitrogen is 28. If you're not sure where that comes from, get out your periodic table, look at the chemical formula, get out your calculator, push some buttons, you'll get 28. If you don't, there's a problem. Mass divided by molar mass, and we get 1.129 moles of nitrogen. Now we've talked about rounding already. I'm carrying along a few extra decimal places, and that's okay. So we're done with figuring out how many moles we've got. Now, of course, there's other things going on. The second step was to convert the moles that we know, which we just calculated, into the moles that we don't know. That's using the ratio that we did a few minutes ago. So in other words, the question now becomes how many moles of hydrogen would react with those 1.12 moles of nitrogen that we just figured out. Well, that's our ratio based on the recipe. And the recipe, if you recall, was nitrogen plus 3 moles of hydrogen react to form products. So this is where I get my 1 and 3, and I just need to be careful about what goes on top. Solving that ratio, I get 3.386 moles of hydrogen. Now, if you think about this for a moment, where did we get this number? Well, this original number came from the mass. So in other words, if I combine step 1 and step 2, I now took my mass, 31.6 grams, and converted it into moles of hydrogen. Not moles of nitrogen, but moles of hydrogen. So taking those two steps together, this is what I've accomplished. Step 3, almost done. Convert those moles of unknown, into the mass of the unknown, because the question was how many grams. So I now know that I'm working with 3.386 moles of hydrogen. What would that weigh? Well, that's mass times, the mass then is number of moles times the molar mass. Same triangle that we had from a moment ago. Right, number of moles on the bottom, molar mass on the bottom, mass in that top corner, but I don't really have room to write it in. Molar mass of hydrogen, 2 grams. Number of moles, which we calculated from before, 3.386. Solve that, and I have 6.77 grams. Now, if I combine all those steps, I took my mass of nitrogen, figured out numbers of moles of it, figured out what that meant for moles of hydrogen, and now I've calculated the mass of that hydrogen. So all those 3 steps combine to be the answer to this one question. Don't write this down, but that was the original question. What mass of hydrogen, which I now know, 6.67 grams, is required to react with 6.77, is required to react with 31.6 grams of nitrogen. So, quick little recap. These are the steps that we're going to have to do every single time. Okay? Pause it, write it down if you need it to, but you probably already have those steps. We're going to do the same things every single time. Okay? I'm getting a little bit tight for time though. You have to do those steps every time. Okay, I'm going to try this one. We're going to have to go through a little bit more quickly because I'm running out of time. But here's a different reaction. And the question is what mass for 53.6 grams. Okay, so I've got this one and this one. I can ignore those two. Okay, convert the mass of known to the moles of known. Same formula, except now it's going to be this mass and that molar mass. I'm going to convert the moles of known to the moles of unknown, the ratio, and the recipe is based on 3 carbon dioxides, 4 waters. And then finally, you're going to have the number of moles of carbon that you carbon dioxide rather, that you calculated, multiplied by its molar mass to figure out the mass of carbon dioxide. Okay, so trying that, we get these numbers. Okay, 2.28 moles of water. Converting onto the ratio, and again, these numbers come from the balanced chemical reaction, 3 and 4. This number, 2.98, comes from the previous step. 2.235 moles of carbon dioxide, solving that ratio. And then multiplying by the molar mass of carbon dioxide to get the number of moles of carbon dioxide. Molar mass of carbon dioxide, 44 grams, and we end up with 98.34 grams of carbon dioxide. Okay? Same steps every single time. Okay, you've got the question down. If you did the end step number 1, you get this. Step number 2, 4.80 moles of oxygen and 153.7 grams of oxygen as your final answer. Okay, one to leave you with. This is one I need you to do, and we'll take it up in class. We'll check it when we get there. And then after that, we're going to be doing a lot of stoichiometry. So if you're still kind of shaky on it right now, hopefully you'll get a lot more comfortable quite quickly. But it's something that we're going to be doing a lot of as we move forward. And yeah, we'll be talking to you in class. Take care.